into 2020. We're in 2019 now, but it is showing its age a little bit. We had to kind of think about this a little bit because, Java has had some issues. As mentioned in the previous session and also mentioned in my session, by default with Java 8, it blew up in a container. So, Java would see all the memory of the host, all the memory of the server, and try to allocate all that memory. And of course, C groups and Linux container technology would say, no, you don't have access to that memory, and I'll shut you down. And so we had to think about that and that specific issue. There's a whole presentation by myself, called Java Docker Fail. There's a great blog post. You can go read about it. But we had to think about that issue and also figure out how to optimize Java for this container thing. So we actually spent a lot of money to invest in Java because there's so much goodness in the Java ecosystem. There's still so many frameworks. There's still such a great economic opportunity for all of you. There's just an amazing amount of tools and utilities and capabilities in the Java ecosystem that make Java what it is. So it actually wasn't the JVM that was problematic for containers, and it wasn't the Java programming language that was problematic for containers. It was actually all the frameworks and that ecosystem that's problematic for containers. Because frameworks were built thinking that they could always do dynamic class loading. They could always do annotation scanning once they dynamically loaded the classes. And then after they parse all those annotations, they could do dynamic reflection to basically get you all the, to get your injection and all your other capabilities. Well, the challenge with all that is that it takes boot time to do that. It takes CPU cycles to do all that. It takes threads to do all that. And it takes memory to do all that. And it's actually memory that cannot be reclaimed. So what if you could flatten that structure in such a way so it does not have to dynamically load all the classes at runtime? It does not have to dynamically scan everything at runtime. It does not have to dynamically reflect everything at runtime. What if you could do that in advance? So that's what we did with Quercus, all right? You're going to see so much of that. So this concept of Duke right here, gathering everything, it basically, started showing its I'm middle-aged at this point. It's starting to show its age. It starts putting on a little weight because we keep loading in all these high-calorie frameworks. Right, all these things like Hibernate, if you go loaded in there. And the problem when we loaded Duke and his slightly overweight self into the container and we put the constraints on him, of course, it blows up. Okay, so you don't want him to go boom any longer. So what we're going to do is put him on a hardcore diet because in this scenario, when we have Linux containers and we want to scale out to a bunch of Linux containers, we want to basically scale out quickly. We want to scale out and scale back quickly. So that concept of having a much lighter weight and faster boot time is critical. Okay, so let me take you back to 1999 for 1 second. So I do this because it's always fun to do this in Europe. Last night I was watching on TV a little bit of, before I went to bed, Juventus on, was on a local sports channel. So I imagine here people are fans of a certain type of sport, right? You guys are fans of soccer, football. Is that true? Oh, okay, well, that's fine. You might love hockey or basketball. I saw NBA there and hockey and some MMA as well. But I'm actually a big football fan, a big soccer fan, because I coached soccer for 14 years and spent a lot of time there. And do you guys remember back in 1999 when the U.S. won the World Cup? It was a very proud moment for me as an American. Seriously, we won the World Cup. And I actually do this because it's amazing all throughout Europe how many people go, no, you didn't, right? No, you didn't. You think I'm lying. I'm not lying. We won the World Cup. Now, here's the part that's more profound, and most of you won't get what I'm about to see, but some of you will. The fact that you did not know that is because you have a mental bias, and you don't feel that people of the other gender can play the sport. You also don't think they can code sometimes, too. So I want you to just keep that in the back of your mind, because everybody can play this sport, and I can guarantee you that the girls I used to coach could take any 11 of you right here and now and destroy you. I'm not playing. My girls could play. And they were very proud when they saw this moment in time where they actually understood that women could play at a very high level. But I just make that point because we all have these mental biases. We all have these issues within our own brain, and we forget to look outside our box, okay? We have a different perspective. Because I also want to tell you about this, because back in 1999, the reason I took you back to 1999 is we used to build Java-based applications, and this is how much it costs to build Hello World. You might think I'm kidding about this, but I used to do this as a consultant. I used to go out and then charge my billable rate over and above this cost. So you were into the $1 million project start cost every time you start a new Java project. You had your application server cost for the hardware, right? You had to have a database server and an application server. And I had someone from Old School Sun look up in the Old School price book about what it cost. We had to buy BA WebLogic back then because that's what we used to use. There was no open source app server back in 1999. We had to buy databases back then because MySQL and Postgres weren't legit, if you will, back then. And we had to buy the operating system to put on that Solaris box, right? Solaris on those Sun boxes. We even had to buy the IDE. Look how expensive the development editor was back then. And then, of course, we had that capital expenditure, and then we had an operations expenditure. Every year, we spent another $80,000 on this stack. So I want you to put that in perspective, because today, with the modernization, we live the modern world of the cloud. Now we spend 2 cents an hour, 20 cents an hour, $1 an hour, whatever it might be. But we can actually start that Java project for all of $5 versus the $500,000. And now all that money goes to the billable consultant, like you. Isn't that awesome? No, but I want you thinking about that because the world has changed so dramatically just in that period of time. So think about it from Java being born back in 1996. Java was born long before there was a Linux in the enterprise, long before there was a Linux container, long before there was the C groups and all the other technology that makes up Linux containers, long before the cloud, long before we saw microservices and distributed computing. It was born in the world when it could own the whole Solaris machine. It was a little different model back then. Now we're living in a world where we need these tiny little applications. We sometimes refer to them as microservices or functions. We need them to scale out quickly. But you can see the world we've gone through just in that 23 years or so. Okay, the world has changed a lot. And if you come all the way up to 2013, 2014, so Spring Boot, Kubernetes, Docker, and of course, microservices being officially defined, all that happened leading up into 2015. And I make that point because in 2015, I did a demonstration for Red Hat where we showed the world what a Linux container could do for you. We basically stood on stage and launched 1,026 Linux containers in 2.5 minutes. We wanted to show the world what it meant to stand up 1,000 application servers like that in an instant. And the problem was we had at this time, and I'm a Java guy, we could only do that with Node.js. It was the only thing lightweight enough to pull it off. So we've been thinking about this issue for a lot of years now. Why is Java too fat and slow for this new modern world of containers, this new modern world of microservices in a cloud native way? So is there a way to solve it? And so that's what we've been working on. But if you look at this set of quotes right here, you can go to the Reddit list here, the link. People have asked, hey, can I use like Java for like Amazon Lambda? And people are like, no, you would never use Java for Amazon Lambda. It's too fat and slow. It takes too long. It's too big. And it's not really Java itself again. Java itself can be somewhat problematic, but it's really more the issue of all the frameworks on top of Java that take too long. And so this is a bunch of interesting quotes that I pulled out of there. But even when we just launched Quercus just a couple months ago in March, the first thing people said to us, you can actually go find the Reddit thread where I'm like, hey, here's the cool thing we just did. People immediately attacked it and said, why would you spend any money at all on Java? It is old. And the issue is Java may be old, but it actually can be renewed. And it's incredibly popular and incredibly important to our economics. So that's what we did with Quercus, right? Supersonic Java. And we're going to show you this thing. So what is this Quercus all about? It is basically about 10 times smaller and about 100 times faster than what you've had before. In other words, it is massively different than what you had before. And I'm going to try to show you that in a little demonstration. There's also a bunch of things that we have here from a developer love standpoint. So in other words, there's a bunch of things we've done just for developer experience, just to make it easier for developers to work with. And if you do have a background in Node.js or some other technology, you're going to see some things you're like, wow, that works a little bit like what I'm used to. Now, if you're an old school Java person, you're like, wow, this is kind of weird, but we'll show it to you. Okay, so live reload you're going to see. There's also the ability to marry the imperative and reactive programming model. There's built for serverless architecture, that dynamic scale up and scale back. It's optimized for your traditional enterprise type programming model. For instance, a RESTful API using JAX-RS, using JPA to persist to the database, using this thing called Hibernate. Perhaps you've heard of it. So all that is part of this architecture. And we also love Kubernetes. I'm going to run this thing on Kubernetes to show you what it looks like. We showed you that yesterday, but we'll show you a different demo today. So let's get into demo mode. Okay, that's enough intro stuff. Let's actually show you this thing. What I want to do now is get out of these slides. Let's check on the network connectivity. Let's see here, kubectl. I want to see if my network is up. Namespaces. All right, so I'm still connected to that big old cluster I did yesterday. You can see I got a lot of namespaces, a lot of pods, but we're not going to use that just yet. What we're going to do is we're going to build a little project. Okay, so mkdir. Okay, mkdir. I'm going to just call this, we just call it Riga. Yeah, fantastic. Change into that directory. There's nothing here so far. There's nothing up my sleeve, as the magician says. All right, but I'm going to go in here, and I'm going to take you to the Quercus website. So the Quercus website is really cool. You can kind of see there's this getting started link here. There's some cartoons and some information about how much smaller it is versus traditional solutions. Again, imperative and reactive. The fact that we can basically save. So remember this piece: edit, save, refresh. Edit, save, refresh. Okay, very different way to program in Java. We're going to show you that in a second. All these cool libraries that we've optimized for this new small world of living in this subatomic world for Quercus. And by the way, you guys know where the word Quercus comes from, right? Quark, the subatomic particle. Us, the best part of software. All us humans. Okay, so I'm going to go into the Getting Started guide, which is right here. And I'm going to grab this one thing. I'm going to basically use this Maven plugin. This means I can come over here and drop to my command line, paste that in, and I'm going to basically do this now. So it's going to ask me for my package name. Let's do that. Let's spell Riga correctly. And we're going to call this the Riga project 1.0. Yes, go ahead and build a default REST endpoint for me. And the reason I want that is to kind of have some code out of the box. So now my favorite editor is Visual Studio Code. Let's open it up. Okay, and now you can see what that thing looks like. Let's close this. This is what was generated for me automatically. There's a couple Docker files. There's a little bit of Java code right here. There's a resources file, both application.properties as well as a index.html, and there's a couple tests. So that's basically it. But let's go ahead and actually have a little fun with this thing right now. So I'm going to come into the terminal. I'm going to say new terminal, and I'm going to say Maven compile Quercus dev. So the first thing I'm going to do is kick it into dev mode. So with development mode, this is that edit, save, refresh I was talking about earlier. It sets up the debugger and everything else, but I don't have to mess with that. And now I'm in dev mode. I can come over here to my local host, 8080, and this is actually the hello endpoint. Well, let's just go here. So I got that. That's the index.html, and here's the hello endpoint. Okay, and now I can come over here and say make this change. Let's go with hola. Helps if you hit the right keys, Burr. All right, hola. Whoop. Yeah, come on, come back. Hit save. There we go. So edit, save, refresh. And let's get a better version of this in here for you guys. Okay. And I did spell it correctly, right? All right, fantastic. But that concept right there, what I just showed you, as a Java person, you might be thinking, I kind of sort of had that before. And then you might be thinking, no, I had to pay for that before. I had to buy this plugin called JRebel, and it worked with IntelliJ and Eclipse. Or you might be thinking, oh, I'd done Node before, and that's how Node works. Exactly. Okay? So if you're a Node developer, what I just showed you is that's natural. As a Java developer, you're like, that might be a little bit weird. But I love this concept. So I can kind of interactively just change the application from Riga, okay, and then edit, save, refresh. It's kind of the idea. And then if I want to also come over here and look at my test, I can say, well, let's run the test. I can run them interactively. Let's run test. I can do those as well. I can basically have the whole test-driven development if I want also. Oh, and then you can say I failed my test. And if I look at the X here, it'll tell me what the wrong thing is. And of course, I changed it from hello to Saviki. Is that close? I'm getting closer on the pronunciation. From Riga. And let's run test again. Close that. Let's see if we get green. And let's see here. Did it run the test? Oh, it helps if you save too, right? Okay, so let's see if we get that right. And test session is currently running. Please wait until it finishes. What do you mean it's running? Okay. Now my IDE here is not sure what's running. There we go. All right, so there we go. We got all green. But that is not that interesting. If I just showed you hello world, you'd be like, whatever, not a big deal. So let's go ahead and build something real now. I'm going to come over here and hit Control-C in my dev mode. And let's actually go back to the real terminal here. And make sure we have enough room. Okay, so Maven, Quercus, list, extensions. So one of the things we've done is, as I mentioned earlier, we've gone out and optimized a certain set of libraries, a certain set of frameworks to make sure that they're available to you in this new subatomic world that we're living in. And so I want to build an application now that actually uses a database and actually talks to a REST endpoint. So a REST endpoint that talks to a database. Let me go ahead and paste this in, put the equal sign, and let me grab the libraries I need. So I want PostgreSQL. I'm going to talk to Postgres. Let's try that. And let's see, what else do we want here? We want, let's say I could go Camel and Finispan, Flyway. I'm going to use Panache. I want to show you the Panache programming model, which is based on Hibernate. It is Panache is Hibernate made easy. And let me also get JSONB because we're going to serialize everything into JSON right from the database. So we're going to do that. I'm going to hit return there. And there we go. We've added those extensions. And what that little plugin trick did was it modified my POM XML. So I'm going to say reload the POM XML. Let's kind of look at it real fast. And then now you're thinking, well, can I do this without XML and use Gradle? Sure. Okay, you could have a Gradle option here if you wanted to as well, but I'm kind of an old school Maven person. So, all right, great. I have those 3 libraries. Let me go back into my dev mode because I want that interactive dev mode. And let's kind of try some things here. So I'm going to go back over here to this namespace. Let's add an entity. Okay, so to-do.java. And I'm going to say, let's add the class. And we're going to make an entity. Okay, add entity. If you guys are familiar with traditional programming or traditional enterprise programming, you basically do things like this. This is called JPA, Java Persistence Architecture. You might know it as Hibernate if you're familiar with that concept. And I want this entity. And now I'm going to do something a little bit different. I'm going to extend Panache entity. Okay, let's see here. Come on, extends. Helps you spell extends correctly. And Panache entity. There we go. Let's see, get the right import there. Import, come on, import. Here we go. There we go. All right, fantastic. And now I basically have to declare, normally this is where you declare your properties, right? In my case, I have 3 properties. 3 different properties I want to declare. But at the same time, you normally have all your getters and setters. Let me show you what's different about this. Okay, so public string, I want the title. Public, let's say Boolean. Is it a completed to-do item or not? And then I want the public int, the order of these to-do items. And I do note that this actually causes some heartburn for databases, the word order, right? Because it's a reserved word in some databases. So I'm going to say name equal ordering, just to kind of give it a different name. I'm going to hit save there. Okay, and remember, edit, save, refresh. Let's go hit refresh. Oh, and I got an issue. Let's see here. Hibernate. Oh, no JDBC driver, Quercus data source driver. Because I have to set up my JDBC driver. Let's try to remember that one. But here's kind of a cool thing. What you just saw is, so my application properties is empty. I have that luckily over here in a little place I can copy and paste. And actually, one of the things we're going to be doing in the future is make it so it injects these automatically. Copy, paste. There we go. And let's just call this Riga. And what I need to do now, okay, we're almost okay, but I need to actually go to my database engine and set up that database. So let's go over here to PostgreSQL. This is pgadmin. I call this thing myRiga, right? Well, helps if you spell myRiga correctly. Copy. And I'm going to give it the password of myRiga. And let's just go ahead and make this a super user so it can do everything it needs to do. And for development mode, that works cool. That works out well. Create a database. This will give me an empty database. Map it to the right user ID. And I don't know if you guys use Postgres. I like Postgres. It's my favorite relational database. And here's my schemas, public. And let's see here. And there's no tables right now. So if you look right there, tables is empty. And so what I want to be able to do is go back over here and let's hit refresh. Okay. All right. Now let's go over here and hit refresh. And now I have a to-do table with all my columns. Okay? So the schema has been dynamically generated for me. Now, if you're familiar with Hibernate, we've done this before. The difference is in the succinct syntax. I did it in a very easier way now, right? There was just a simple set of application properties and a couple public properties, public attributes for that that class, that to-do class. So I could go back and forth and just simply interact with it like this. I could easily add more things to my database schema, but I'm not going to worry about that right now. We don't have a whole lot of time. So I want to actually now build an application that does something with that entity. So I'm going to come over here and say I want a new class. Let's call this to-do resource. In this case, we're going to leave the JPA world and more go into the JAX-RS world. So let's add a new class here. Okay, I'm going to say at path because that's the annotation you use in JAX-RS world. Let's not do that. Let's go here, and I'm going to add this, make this root. Okay, and actually I'm going to go ahead and just make that include all of those. And then let me also do the produces. There we go. Media type. I'm going to produce JSON. Application JSON. Come on. Oh, look at that. This has happened to me before. No, not the wrong media type. Media type. application JSON. Let's get the right one, therefore. All right, there we go. And I want to consume application JSON. So basically, this endpoint is going to produce and consume JSON. No big deal there. And produce and consume JSON. And did I misspell consume? Let's see here. There. Okay. I did. Okay. So we have to get produces and consumes. You can tell this is live. I'm kind of making this up as I go in some cases. All right. So what we need to do now is say at get, because we want to basically, as you get, right, HTTP get into this resource, I want to say public, let's do a list of to-do items. Remember that to-do class we created earlier. Get all. Okay. And I want to return to-do.list all. So there's a convenience method that's been added that lets me do that. And I can even do something like a sort by, let's sort by the order column that we mentioned earlier. Oh, let me get the right import for my list. That's a Java util list. And of course, let me get the right sort. Let's see here. And that is a panache common. So the sort is a panache feature, if you'll see that right there. So list all and sort. So panache, again, makes things easier, right? Its goal is to basically make it so we can actually interact with our application in an easier way, or our database model in an easier way. So let me go to the root here. Okay. Oh, and that's the index.html that I mentioned earlier. So let me actually fix that real quick. I have a different user interface. And then this is the Riga run, right? So, okay, you'll see right here under main meta inf resources, that's the index.html that's being served. I can delete that. Okay. And then hit refresh. So you can edit not only the .java files, but the .properties file, as well as the various HTML files too. So, okay, there's an empty array because there's nothing in the database right now. So I don't have anything in the database, but let me go ahead and add my user interface. So the good news is I'm using an endpoint that works with the to-do MVC user interface. So I'm going to just copy and paste the to-do MVC user interface. Let's go to Riga again. Main resources. There we go. Drop it in there. Paste those things in. And paste. Okay, if I did that right, it is actually under the URL to-do HTML. Okay, there's the UI. This is to-do MVC. It's an open source. There's to-do backend and there's to-do MVC. And you'll see that out there on the internet, right? So basically, it gives you React, Vue. This is the Vue version, jQuery, AngularJS, Backbone, etc. Just different options for the same user interface to kind of show you the different JavaScript client sides. And I can use it with my backend now. All right, so that's what we're about to do. Okay, so now we need to be in the mode of being able to add a record to the database. So what I need to do now is add post. Okay, so public, we're going to return a response. We're going to basically add one. And we're going to add a to-do item. Okay, so we're going to basically say item.persist. And then we're going to do a return response. Okay, let's return the item and the status. Okay, we can use this. There's all these different status. We'll just go ahead and hard code it to 201. Right, so we've added the item. And, I need to do the import here. Let's try to get that right. Import JAX-RS core. There we go. All right, so there's my post. Oh, and I need to make this transactional. Sometimes I forget this. So let's make it transactional. Transactional. Because we want it to really persist in a transactional way. So this is a truly transactional application. So that should be, you should keep that in mind. You know, a real database transaction. Let's see here. 1, 2, 3. If I did that correctly, let's go refresh. We'll find out. This is the moment of truth. And 1, 2, 3. We're transactional to the database at this point. So 1, 2, 3. Okay, so that's pretty cool. If I want to come here now and let's try to, more stuff. So now we're adding to the database, which is pretty awesome. But notice right here, I have a problem. I can add the same to-do item more than once, and that's not very cool. So let's add a little bit of validation to it. So I'm going to come back to to-do over here. Let's make sure that you can't add a blank one. And more importantly, column. There we go. We want to make it so that it is unique equal true. So you have to have unique to-do items. So let me come over here and hit refresh. Notice what happens when I hit refresh. Basically, every time Korkis has decided in live dev mode that you are changing things, again, whatever files you change, it basically, when you set a refresh, it basically reloads the entire application context. And what's happening, and the reason all my data just went away, is if I look at my application properties, it has drop and create for Hibernate's ORM generation. right? For the schema generation, it basically says drop the table, recreate the table every time you hit refresh, basically. You can change that to just update or none, depending on what mode you want to be in. But drop and create's pretty cool because I'm still messing around here. So 1, 2, 3, and so 1, and now it won't let me add it. 2 won't let me add it. And actually, there is a message being shown here, right, for that error. I'm just not displaying it to the user. Okay, so that's cool. Now I have that kind of validation in place. Let me go ahead and add a couple more things while we have a few more minutes left. Let's add a delete. Okay, so delete. And for delete, we want it to be transactional also. And in the case of delete, it has a path. It has the ID. Dun, dun. And so public response. Okay, delete one. It's hard typing in front of all you folks. Path param ID. And that's a long ID coming out of there. And yeah, okay, great. So to do entity, declare our to do item is going to be to do find by ID. Fantastic. Okay, and again, this is Visual Studio Code. I don't know if I mentioned this yesterday. Basically, we work with Microsoft on Visual Studio Code at Red Hat. So you can see this is basically Red Hat's contribution to the Visual Studio Code ecosystem. It's all free, all open source, and it's about 17 million downloads at this point. So that's the tool that my team works on. One of my teams work on at Red Hat. So I kind of like it. So that's what I'm messing around here with. All right, so we got our to do. Oh, we got to do a delete. Okay, let's delete it, and then let's return a response. Status. And we're going to return a 204. I think it's the proper response. There we go. Build. And let's see if we do that right. Hit save. Okay. And watch what happens when we refresh. Remember that drop and create? Okay, everything's gone again. So I can type it back in. Now, you can change that any way you want. There's also the import SQL feature in Hibernate where you basically can have the default set of records already there. But let's try to delete 2 of these. And let's come over here and hit refresh on our database. I actually do love coming back to the database itself and validating that what I think I did programmatically is true. Now, this is because I'm old, okay? I started back in the days when relational databases were born, and you weren't really sure if your data really made it to the database. So I like going to the database user interface and double checking that what I thought is true is in fact true. So we have a delete now. That's awesome. We can no longer add duplicates. We can only add, new stuff. That's cool, and we can also delete. But let's see, we can and 1. And let's see, we can't do an update yet. Let's double check that. So let's do a double check of that. And yeah, so it says 1, not 1 and 1 right there. So let's do the update real fast. We have a few more minutes left. Let's add a little bit more code. You guys ready for that? Okay, is this at all remotely entertaining? Okay, patch. Again, transactional. Oh, as a matter of fact, let's cheat a little bit. It's virtually the same as the delete. Let's grab those first set of lines. And we're going to update 1. And the difference is, let me add the closing curly brace before I forget about it. And let's do it's a to-do item coming in as well. So we're going to update. Dun, 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 dun. And okay, so entity dot completed equal to item dot completed. Great. Entity dot order equal to item.order. Fantastic. Entity.title. There we go. Item.title. All right. And entity.id equal to the ID that came in. Return response. Let's see. Okay. And we're going to return. Okay. With the entity that was just updated. Status 200. And build. Okay. Did I do that right? Okay, there's no little error messages. And by the way, if there was an error, again, like you saw earlier, if I come over here and hit refresh, okay, you see there's a missing semicolon. So I love that aspect also as well. So if you're using VI and you don't have the real-time syntax checking, you can still get that real-time syntax checking in your browser, which again, if you're a Node.js person, you're like, that's the way the world's supposed to work. But as a Java person, it's very different, right? So 1, 2, 3, love Java. Let me update this to learn Quercus. Let's see here. Type correctly, Burr. And if I come back to my user, let's double check everything. All rows, and there's learn Quercus love Java. Okay. All right. So yeah, and there's also this little thing over here. We can basically say, and we already love Java. So let's check that as done and hit refresh. And you can see it now. It says completed true right there. Okay. All right. So that is our application, more or less. There's other things I could do to it, but that's a decently working little application with some real validation logic and other things. Now what you want to do is Maven package. Well, let me do this real quick. I'm going to leave dev mode now. Let's go into production mode. So let's say that's my app I want to deploy to production. I'm going to say Maven package. Okay. It helps if you're in the right directory. Dun, 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 dun. There we go. All right. So we're doing a Maven package here, and this is a standard Maven package, which creates the Uber jar. There's a distinction, though, with our Uber jar versus, let's say, a traditional Drop Wizard, Vertex, Spring Boot type Uber jar. And that is, it's actually a thin jar. So if I come over here to target, LN, right here, you'll see that the jar file is only 1.1 meg because we actually learned a thing about Linux containers. If you want to optimize the Linux container performance, and both that's the build time performance as well as the distribution performance, you don't put all your application server logic, your infrastructure logic, in the business logic jar. You separate those two worlds. So this is just the business logic jar, the things you saw me editing. The actual infrastructure is in the lib directory. So I don't have to carry that around with me. So if I have a ton of other jars that are supporting, I don't have to carry that in my overall runtime, but I can still do a java-jar Riga runner.jar. There we go. And we're up and running. So that started in 1.25 seconds. So that's pretty fast all by itself. And that's in JVM mode. And again, I can come over here now and play with it some more. 3. Okay. So the application looks like it's working. Fantastic. But now what I want to do is something a little bit different. All right. That is just JVM mode. Now here's where it gets interesting. What we've done is we've also basically said, well, let's do this. While we're talking, I'm going to also package it for native execution. Okay. Now this actually takes a little bit of time. P native. What's it complaining about here? Does not exist. Profile native. What's that? Oh, I'm in target. Yeah, you're right. That's a good one. Yeah, let's go. Okay. Now it should be happy. All right. So we're going to compile this for native execution. This uses a technology called Growl Vm. Growl Vm. All right. So Growl, let's come down here to where we have Growl Vm. Okay. This guy right here. And here's why this is important to us. And we'll try to explain what it's doing. So Growl Vm is basically saying, okay, we're going to take your Java application. It uses a feature called substrate and native image there. We're going to take your Java application and we're going to basically dead code eliminate it, if you will. In other words, there's tons of things that I am not using on a regular basis. Okay. Like, let's go back here. Come on. There's tons of things I'm not using on a regular basis, and I want to make sure that I'm focused on exactly just the things I'm using. For instance, in Hibernate, a lot of people here probably use Hibernate already, I'm assuming, right? Hibernate Object Relational Mapping is one of the most popular Java frameworks in the world. But if you use Hibernate, you might connect to Postgres, or you might connect to Oracle, or you might connect to MySQL. You guys familiar with that, right? And you can move your application across to different database schemas. That's why you love Hibernate, because you can move from one database to another. But guess what? Inside of Hibernate, you have all this Oracle stuff, right? For mapping to Oracle. What happens if you just want to connect to Postgres like I just did? Well, you don't need all the Oracle stuff. There's approximately 400 places Oracle shows up in Hibernate, and this gets removed now. Why carry all that Oracle stuff with me if I only want to talk in Postgres? So that means what's happening here is basically anything that's not used is getting removed from my application right now. And this means it'll run even faster. It'll be even smaller. And it also comes down to a native executable that's in Linux, and you just run that native executable without any other JVM required. So that's kind of the cool thing. But the reason we did this, again, is because of Kubernetes. So I'm going to mention this. So Kubernetes, as we mentioned yesterday, has this concept of the master, right? The master basically is the owner of the cluster, and there's typically 3 masters in all cases. A real production cluster has 3 masters because you have etcd in there, and etcd needs 3 of itself to have quorum. And you're going to update whenever you say, I want a new deployment, I want a new application, you basically are updating a database record in etcd that comes through the API layer you see here. And then the schedulers and controllers kick in to make it real. You say, I want 4 of these and 2 of those and I want 2 Postgreses and 1 to-do application. And it makes it happen for you, right? That's the beauty of Kubernetes, the declarative syntax that you have. And so you'll do things like this. I have my 6 nodes here. You can see there's my 6 different nodes and my master node there. And I will basically make a declaration like I need 2 of these customer service applications, and it'll put the 2 of them out there. So if you watch closely, I want 2 little tomcats, and it adds the 2 tomcats around the cluster. And then, of course, it load balances across them accordingly, which is nice. Okay? But what you can do now with this Quercus technology is if I want to have 20, I can do it. Because in the same memory footprint that I did 2 things before, now I can have 20 things or more. So that becomes important when you have to dynamically scale out rapidly. And I showed you a little bit of that yesterday when I showed you the Knative piece. But what I want to do now is kind of change the game here a little bit. Let's go back over here. Oh, and it actually finished it already finished our creation of our native executable. So let's go into target again. Whoop, LH. Look here. Here it is, 55 megabytes, and there's no JVM. It's the same application you saw earlier. Let's run it. Notice it started in 0.04 seconds. Okay, that is the whole app. It is up and running. So let's go mess with it. Okay, so I can hit refresh in my browser again. Okay, love Java. Learn Quarkus. Be awesome. Okay, and let's go check our database to see if in fact it's real. I'm hoping it's real because, I've been telling it's real. Let's see here. Open all rows. And there we go. Okay, so think about that for a second. It basically loaded up the entire application, set up everything I needed entirely, my entire scaffold application with the REST endpoint, with the get, put, post, and delete, with the connection pool to the database, with the schema generated, ready to rock in 0.04 seconds. And so that kind of changes the game for what you can do in a container. Again, I can run it again, right? Let's run it again one more time. Ooh, it got a little faster this time. Okay. So just think about that for a second. And what I want to show you is what this means in the context of containers. So this is the to-do application I've already finished. Okay. All right. Clear. All right. So kubectl, get namespaces. Let me make sure I'm double connected to my cluster still. All right. Kube.ns, what namespace am I in? I'm in to-do. Fantastic. Kubectl, get pods. And I've got this one. So this is the to-do application with the Postgres deployed out there in my cluster at this point. So that's the same Postgres, but one to-do application. Let's do this now. And actually I have this little poller. Okay, so we can hit up against an endpoint. See where it says host and the count there? Let's see, this is the one that's finished. Okay, so it's going after this pod host API, and it's just returning the host name, because I like returning the host name to see the computer the Java thinks it's running on. Okay, so, and I basically have version 2 out in production. Let's go ahead and push version 3. Okay, so let's go ahead and push version 3. Dun, dun, dun. So we're deploying version 3 right now. Let me actually watch kube control get pods. Kube control, all right. You can see the old one getting torn down and the new one creating. So this little concept right here of how long it takes to create that pod could be important to my application. If I have to dynamically scale out rapidly, what happened there is important. So it just rolled that out. So let's try to pull it again. There's host 3. Okay, and you notice, see the host identifier changed here between these two. It's a different computer. A whole different computer was spun up from a JVM standpoint, from Java standpoint. And technically there's no JVM because there's the compiled to native executable. But man, that's kind of interesting. Let's try this. Let's do this poll again. All right. And let's kind of make this a little bit bigger here. Let's watch our pods again. Kube control get pods. Okay. Now I'm going to go into the UI for this thing. Right here, this is the deployment I've been messing with. So there it is. So I was using the command line, but this is the GUI side of it. And you kind of see there's pods, deployment configs, all your standard Kubernetes objects here. And as I mentioned yesterday, OpenShift is Red Hat's supported distribution of Kubernetes, but it is just Kubernetes. I can kind of also see, I can look at all the machines. So there's actually a whole bunch of servers back here. You can kind of see there's 6 different worker nodes. So if you remember my slide, 6 different worker nodes, same kind of concept, 6 different worker nodes there. And so basically, those are the computers that I'm putting all my application around. But let me come back to my deployments, and let's go to to-do. And we'll come over here, and we're going to go to this one. And I'm going to basically, let's crank it up. Let's go at 10. I want 10 new servers because I have a bunch of people, I have a bunch of customers coming online. I need 10 servers instead of 1. Okay, and you can see the container creating. It's going through the process right now because, again, the declarative state has changed. I said, hey, Kubernetes, I know I told you 1, but now I need 10. And it goes out there and tries to get it going as fast as possible. They're already running, connected to the database, and you can see they're being in the load balancer already. So again, you can now basically live in a world where you don't have to scale for peak any longer with Java. Okay. Normally, if you think you need 10 servers because that's your peak load for noon or 9 or Tuesdays or Saturday morning because the football game is about to start and all the people log in at the same time to watch the football game, hockey game, volleyball game, whatever sport you love, you can deal with that in a different way because you can scale out that fast. I mean, I really just created right here what you just saw, 10 application servers on the fly. Okay. Maybe, well, heck, let's live a little dangerously. Maybe I think I need a little bit more. My load has grown. I need 5 more. Again, the declarative state has changed. So I say I want 15. You can see here's 5 more coming online. And so I did all of that in a very small memory footprint as well. So while that's coming up, let's actually go here and look at the memory footprint. So you can see one of them is running at, let's say, just under 20 megs of RAM. A couple of them are running at 13 megs of RAM. One of them is running in 7 megs of RAM. So that's smaller than a Node.js app. And it's all Java. And it's talking to the database. It's a real application. Is that cool? Okay. We think this is game-changing and fundamentally changes the way you think of Java going forward. Again, we had people debate with us online. Why would you ever make this investment in Java? It's dead. It should be gone. And we think Java is incredibly viable and incredibly important to the future of our entire ecosystem. And so if we could find a way to make it vastly smaller, vastly faster, let's do so. So we leveraged that Growl technology and basically added all the enterprisey things average developers need on top of it. And of course, made the developer experience smooth. So you have that edit, save, refresh, live reload, edit, save, refresh kind of model. And I now have an application that scales out very easily. Let's kind of get back into slideware mode. Okay. Oh, and I should also notice that if something fails, right? So we have the 20 different replicas here. Right now I have 15. Maybe I should have just gone to 20 to make it equal to slides. How about that? Because I did say 20 in the slides. And I have room and capacity to easily get up to about 50 on this cluster. Depending on what else I'm running, because the cluster, of course, is a shared set of resources for my PostgreSQL databases, for my, my other applications, my Knative applications, right there. And actually, let's do this. I can also downscale. Let's go back to 2. We want HA. Okay, so we're going to downscale, but let me do this. You can see it's killing the other ones right now. And what I showed you yesterday was this concept with Knative. We're going to come over here and say, watch, cube control, get pods. Oh, I'm in the wrong namespace, so let me switch to the right namespace. Project, side by side. We're in the right namespace now. And notice there's no pods in this namespace. But if I come over here and say burst, right, throw a bunch of traffic into it, you'll see it basically will load up and cause a bunch of servers to start for me automatically. So even that concept with Knative basically says, okay, forget about the user having to manually scale. We will auto scale based on HTTP load in real time. So there it goes. All those, our users got a response. It did have to wait 17 seconds, but that was from a true cold start. So in serverless world, you measure cold start latency. This is why it matters that it's so much faster. Okay. And I'll show you this one more time. Here's the Node.js, so you can keep me honest. All right, so kn burst. Let's bring up the Node.js. And you can see it's basically popping in there too. So as long as I keep my total pod count to, let's say, around 60 to 70, I have enough server overall cluster capacity for that. But think about that. That is 60 to 70 applications running inside my application cluster here, or inside my cluster, my Kubernetes cluster. We've easily taken this up to much higher numbers. As I mentioned, we did one system where we launched 1,000 of these simultaneously just to make the point. You can see it took 23 seconds, but that, again, the time will vary. It also has to do with the fact that I kind of started abusing the cluster on the other side. So Node is normally a little bit faster than that, but we basically are dealing in a world where Node and Java now are the same speed, and Java is actually slightly smaller. All right, we are basically out of time. Let's go ahead and wrap this thing up. Let's see here. What else do we have in slideware mode? Oh, that's really just it. Okay. So I want you guys to be thinking about this. This is an important thing that we feel that we've done at Red Hat. Of course, it's all open source. You can go to Quercus.io, download. You can do that Maven create thing that you saw me copy and paste into your directory. So build a directory, do the Maven create thing. If you have Maven installed on your machine, it'll just work. And then you can basically give it your package name, add the REST endpoint. You saw me do that earlier, add your own custom business logic and get going, right? So Maven compile Quercus:dev, right? For that dev mode. And then, you can also watch the recording of this video. I think they made a recording and then see exactly what we did here in this particular presentation. But I'm hoping this kind of gives you a feel for the new world Java can live in this container native world where you can make it super fast, super small. This is how we see the world of microservices and serverless going forward when it comes to the Java experience. That's our focus with Korkis. And if you have any feedback for us, feel free to send it our way. I do have about 2 minutes according to this clock to answer a question or two. Is there a question you guys want to throw at me real fast? And I can't really see you very well, but feel free to just yell out. Okay, when will it be production ready? Great question. So this is a brand new baby born in March. Okay, we just gave birth to this thing. If you notice, it was 0.15. It is not yet 1.0. So just keep that in mind. It'll be a little bit longer. We're working our way through that process. Our process right now is focused on innovation, making it ready for people. And we need your feedback. With that said, there are already people who saw it already and put it in production. Because it was so much faster and smaller from the world they came from. They were like, we need that memory and that, because let's put it this way. I gave this presentation just a few weeks ago, and one person walked out of the room and then came to me afterwards and said, you don't understand. This is a big deal for me. I was literally about to start retraining 300 Java developers into Go because Java was too fast and slow. I can stop that now. So literally some people have already put in production because they've been waiting for years to get Java smaller, faster. Another question? Yes, sir. Oh, he's got a microphone.
Thank you. What are the chances that this will ever hit mobile?
Ever hit mobile? You know, that is not, so mobile application development is not a focus for us right now. It might be that that's something we could look at in the future, but very much at Red Hat, we're very focused on the back end, if you will, of the application. That's really where we come from in the enterprise, if you will. So we have large banks, large insurance companies, large governments, large travel companies that use Java with Red Hat on top of Red Hat Enterprise Linux, on top of JBoss application platform, right? You might have heard of JBoss. I mentioned that earlier. On top of all this other infrastructure, our OpenShift, our Kubernetes. And so we're really focused on those use cases for now. But this is a community open project. It might be you find something very clever here and you want to work with us on that. It also would require Growl Vm to be concentrated on maybe deployment to, let's say, a Android world as well, right, for that native compilation component. But you can also just run in JVM mode. So even if you just use the JVM without native compilation, a native binary, you're still faster and smaller. All right? There's always a win with being faster and smaller. And if hopefully you just saw with the live development mode by itself, that by itself could be worth the price of admission. I am officially out of time, but thank you so much for that. Remember the slide deck there is a bit.ly Riga Quercus. That's how you'll get access to it. Oh, and of course, every time I move my mouse over there, it gets lost behind there. There you go. You see it again. Check out the slide deck. Do give us a shout out on Twitter. And of course, give this thing a try. Thank you so much for your time.